This is the final lecture. Next week we're going to do exam prep in this hour. It's an important topic. It's not always students' favorite. We're going to look at environmental accounting. I don't think I'll get to corporate accounting. We'll reserve that for the seminar on Monday. There's two bits that are a bit tough. One is something that is an extension of what you already know, and I also will be forced to introduce a new mathematical method, which also typically thrills students. So this is what I'm going to talk about. As I said, I won't make it to the end. This is where we are. Final lecture, as I said. I'm going to start talking about gross domestic product. This was introduced in 1925 by Simon Kuznets, who we met last week. The same guy, and don't need to introduce this. It is the conventional measure of economic performance, tracking the economy over time, and if you normalize it with the number of people, also comparing economies over space. Kuznets introduced this in 1925. It was first sort of operationalized almost 20 years later. But in 1932, Kuznets already noted that this is a measure of economic activity, which is not the same as a measure of economic welfare. But that confusion has always been there. Lots of people go around and say, well, GDP measures how happy we are, or our welfare, and definitely politicians and journalists constantly fall into this trap. But it is a measure of the activity in an economy and nothing else. As you recall from your principles, there's three ways of measuring GDP. One, you can look at the total demand for goods and services. That doesn't just include demand by consumers, but also demand for investment and so on and so forth. And of course, demand from foreigners, exports and imports need to be included as well. You can measure it as the total value added, so the total production in an economy. And you can measure it as the total income in an economy, not just wages, but also capital income and so on and so forth. And if you had a perfect set of measurements of the economy, the three alternative definitions of GDP would give the same number. But typically that is not what happens, because we can measure the economy only imperfectly, and the three measures hopefully slightly differ from each other, but sometimes in some economies they can differ considerably from each other. But GDP is definitely not the end of our measurement. If that were the case, then I would stop here, right, and send you all home. Robert F. Kennedy, the father of the now infamous Robert F. Kennedy Jr., but the brother of JFK, in 1968 already summarized all the things that are wrong with GDP. Too much and for too long, we seem to have surrendered personal excellence and community values in the mere accumulation of material things. Our gross national product now is over $800 billion a year, but the gross national product counts air pollution and cigarette advertising and ambulances to clear our highways of carnage. It counts special locks on our doors and the jails for the people who break them. It counts the destruction of the redwood and the loss of our natural wonder in chaotic sprawl. It counts napalm, this was during the Vietnam War, and counts nuclear warheads and armored cars for the police to fight the riots in our cities. It counts Whitman's rifles and Speck's knife and the television program which glorify violence in order to sell toys to our children. That concern is nothing new. Yet the gross national product does not allow for the health of our children, the quality of our education, or the joy of their play. It does not include the beauty of our poetry or the strength of our marriages, the intelligence of our public debate, or the integrity of our public officials. Times have changed in some ways. It measures neither our wit nor our courage, neither our wisdom nor our learning, neither our compassion nor our devotion to our country. It measures everything in sort except that what makes life worthwhile. And then, of course, he talks about the USA because he said this during his run for the presidency. And this neatly sums up everything that is right and wrong with GDP, right? It counts what is going on in the market, regardless of whether that is good or bad, and it ignores everything that is outside of the market. So, why not use GDP? Well, the first objection to GDP is, of course, Bastiat's window. That is, if you break a window, that is not counted in GDP. But if you then fix the window, it is included in GDP because that is a market transaction. And really what we should be looking at is not gross domestic product, but net domestic product. Net domestic product subtracts the value of the broken window, right? Another limitation of GDP is that it is limited to those things that are traded on legal markets, right? So subsistence farming, when you grow your own food, is not included in GDP because there's no market transaction. You grow the food, you eat it, that's it. Nobody buys and sells. It counts as positive defensive expenditure. So the locks on doors that RFK was talking about, or if you have coastal protection, that is not good for anything. It just prevents harm. But that is counted as something that is good, right? Criminal activities are typically excluded. So in this country, most drugs are still illegal. And that means that all those transactions that you're not supposed to tell me about, the things that you do on the weekend, that is real economic activity, but it's not included in GDP, right? Some countries had a problem there when they legalized marijuana, that all of a sudden their GDP jumped, right? Because what used to be not counted now becomes a legal market and has to be counted, and you need to somehow smooth it out. But that is one of the limitations of GDP. Environment obviously is excluded. We're going to talk about that. Also, housework is not included in GDP. If you clean your house yourself, that is not a market transaction. It is real work. It's a real activity. It is excluded. Economists used to joke that one way of reducing GDP was to marry your housekeeper. We don't make that joke anymore because we don't think it's funny anymore, because there's been so many scandals around gender and sex in the profession, including in this department, that we don't make this joke anymore. But it is one example of the limitations of GDP. And of course, GDP counts the sum total of economic activity. It doesn't take into account its distribution, nor such more elusive concepts as freedom of speech, freedom of political assembly, and so on and so forth. So there's all sorts of things wrong with GDP, and all of this has been known essentially since 1925, 1932, right? It's still the thing that we measure all the time. Now, why is it important to accurately measure GDP? Well, one thing that you may be interested in is the growth rate of productivity, because that essentially drives how much smarter we're getting, how much better we are getting in making things and doing things, and that of course allows for greater consumption and a reduction in poverty. So let's measure the growth of productivity. And I'm going to assume a very simple economy. This is total output Y, this is total factor productivity, and we have production that uses two factors of production only, that is labor L and the environment E. Now, that is just a static representation. We're interested in growth, so let's change all variables by a little bit. So total factor productivity goes up by delta A, labor goes up by delta L, and environment goes up by delta E. And then as a result, total output goes up by delta Y, right? Now, this doesn't teach us a whole lot. What we can do is use a Taylor expansion on this production function. Taylor expansion, this is the first order Taylor expansion, it's essentially just a linearization. Taylor expansion around LE is essentially the original value plus how much labor changed times the first partial derivative of production to labor plus how much the environment changed plus times, first partial derivative of production to the environment, right? And this is approximately true, right? Now, we can put this expression in here, right? Here we had the FL plus delta, E plus delta. So we have that as here as well. So we substitute this in here. And then we subtract Y from the equation. And Y is, of course, just a FLE. And then we have that the change in output is approximately equal to the change in total factor productivity times the original output, the original production, plus the change in labor times the first partial derivative, plus the change in environment times the first partial derivative of production to this particular input, right? And this is just the same equation that we had before. Now, divide both sides of the equation by Y, and recall that Y is equal to total factor productivity times the production function. So this term here drops out. What we have is that the proportional change in output is the proportional change in total factor productivity, proportional change in labor, proportional change in the environment, their first partial derivatives, and then we have these normalization terms that pop up here that are not particularly useful until we sort of like put the market in its equilibrium. And you may recall, I think from week 2, maybe it was week 3, that the price of labor, the price of the input, is equal to the price of the output times the marginal productivity, right? This was one of the conditions for this is the condition for productive efficiency, right? Right? So we put the market in equilibrium, and then of course what we have is that the first partial derivative of production to labor is the price of labor over the price of our output good, right? Substitute that in here. So this expression, replicate here, we substitute the price ratio in and the marginal price. And we make another substitution because our product mix efficiency the price of the output good is simply the price of the two input goods weighted by their inputs. And we can rename this particular term as the value share of labor. Right? We're almost there. Do the same thing for the environment, and what we have is that our change in total factor productivity can be measured as the change in output minus the change in labor times the factor share of labor minus the change in the environment times the factor share of the environment. Right? So far I've done mostly substitutions. Now, take the first partial derivative to time, and this delta A becomes an A dot. Do that everywhere, and what we have is that the proportional growth rate of total factor productivity is the proportional growth rate of the total economy minus the proportional growth rate of the inputs into production times their price shares, the value shares, sorry. And this is of course something that you recall from macro, right? This is how we do growth accounting. Now, why is it important to have accurate and complete economic accounts? Now, what we started off with is we had an economy that uses two factors of production, labor and the environment. And the environment is very difficult to measure and typically ignored, and it's actually excluded from the definition of GDP because it's not a market transaction. So, whereas the reality is this, our economic accounts or national accounts will give us this. The environment is not included and we have only one factor of production. And that makes that we mismeasure the change in total factor productivity. So one implicit assumption that you make is that the things that we don't measure evolve at the same rate as the things that we do measure. So if we assume that the proportional growth rate of the environment is equal to the proportional growth rate of labor, then, because SL plus SE is always equal to 1, and these two terms are the same, we measure total factor productivity change accurately. But if in reality the environment grows at a different rate than labor, in reality it's L dot over L minus B rather than L dot over L, then the actual growth rate of total factor productivity is this thing here. It's still the change in total output. Still we have labor here, but of course with its value share. We have the value share of the environment here, but the growth rate of the environment is now L dot over L plus B, or minus B, sorry. And what we have is that total factor productivity in reality is this. So we introduce a bias if we exclude one factor of production and assume that it grows at the same rate as the other factors of production that are included, then we introduce a bias that is equal to the differential growth rate, B, times the value share of this particular missing input. And that means that if the state of the environment is important for the productivity or the production in our economy, then our measures of technological progress are biased by this exact amount. And that actually can be quite substantial. This is work by Repetto, whose first name I completely forget at the moment, but this is what he looked like. He's a good bit older now. Because as you can see, the graph stops in 1991. Repetto measured this for the United States, and he had the conventional growth accounting and then the growth accounting with the environment included. That is the solid line. Environment excluded is the dotted line. And what you see in the top graph for electricity, there is a huge gap there. Actually, if you focus on the conventional economic measure, then it seems as if total factor productivity in power generation is falling. But if you include the environment, it is actually growing. And the reason for this is actually that the B here is not negative, or the B is negative. That is, the environment actually improves faster than labor productivity, and that is because we cleaned up mostly the sulfur and other particulates coming out of the environment. He finds a similar but less dramatic, qualitatively similar but quantitatively less dramatic effect for agriculture, where also if you include the environment, total factor productivity is actually growing faster than it would seem if you exclude the environment. Again, this has to do with a cleanup, mostly pesticides over this period. In the first half of the period, cleanup of the pesticides from agriculture. In the second half of the period, is mostly going after the phosphates and the nitrates, the causes of eutrophication. But you probably agree that this is actually a major difference, right? So you may wonder, the UK has been suffering from slow productivity growth, if you believe the official statistics. That excludes the environment, right? Could it be that this actually has to do with the change in environmental care, the change in emissions, and actually there's been quite a bit over the last 2 decades. Could that be an explanation for the productivity puzzle in the United Kingdom? A question I leave to you. But measuring economic output correctly, including all the things that matter, is important, as you can see from this graph. Now, how do we measure, how do we correct gross domestic product or net domestic product for the environment? George likes to put in pictures. So this is a nice picture of a meadow. So gross domestic product in a closed economy without a government is defined as consumption plus investment, right? That's one of the 3 definitions. Net domestic product is consumption plus investment minus depreciation, right? So the environmental net domestic product, or the environmental domestic product, should be defined in the same way, right? It should be consumption plus investment minus depreciation plus the services that we get from the environment. That's a form of consumption. It's a form of intangible consumption. We talked about how to put monetary values on that. Some of you have done that or are doing that in your essay, which is really, really finally due on Thursday. And then, of course, we should also subtract. That is for those who have an extension, right? Not for the others. Or for those who took an extension and the penalty, right? That extension. It's finally due on Thursday at 4 o'clock. So plus the environmental services minus, of course, the degradation of the environment. So this is essentially your change in the environmental stock. This can be in the physical capital stock. This can be seen as the change in the environmental capital stock, right? So that would be a logical way to extend this, and it's an intuitive way of doing this. Does it actually make sense? And this is where I'm going to introduce this new mathematical method that you're not familiar with. This goes back to a young and very cocky Marty Weitzman. So, suppose that we want to maximize utility. And utility is a function of consumption, and we have some sort of discount rate, rho, and I'm going to do this in continuous time because that is easier. So instead of having a sum over all future periods, I'm going to take the integral over all future periods. That is, I'm going to move forward in time in infinitesimally small time steps, right? And really working in continuous time sometimes is easier than working in discrete time. And we do this maximization subject to this particular constraint, that our output Q is a function of our capital stock, and our capital stock, so the K dot is the change in the capital stock, is depreciation, or it's investment minus depreciation, and depreciation is of course proportional to the initial capital stock. So this is our equation of motion, and then I substituted investment is of course total output minus consumption, right? So I substituted that particular constraint in here. Now, you do not know how to solve this because nobody has ever taught you this. The method that we're going to use is by Hamilton. Again, his first name escapes me. It is actually, you could try and solve this with Lagrange, but it becomes very, very, very difficult to get any sort of useful insight out of Lagrange, which is the method that you know for solving constraint optimization. Instead, I'm going to rely on Hamilton. Actually, you can show that Hamilton is correct by using Lagrange's method, but I will spare you that. It's a very long derivation, and I'm just going to give you the result. So what you do in a Lagrange optimization is you have your objective function, you have your constraint, and then you form the Lagrangian, right? Now, with Hamilton, you form the Hamiltonian, right? And instead of calling it script L, we call it script H, right? So that is the same, and it just has a different name because it's named after a different man. So the Hamiltonian equals the current objective function. So what you do is you throw away the integral as well as the discount factor, and you just take your current objective. You stick that in here. That's the first element of the Hamiltonian, and it's already simpler than the Lagrangian, right? Now you need to carry much more. And the second difference between Hamilton and Lagrange is that instead of using the constraint, you just take the right-hand side. So we just have the change in the capital stock here, and we multiply that not with a Lagrange multiplier, but with a co-state variable or a Hamilton multiplier, which is just the shadow price, right? So actually the Hamiltonian is a lot simpler than the Lagrangian. Although it is a differential equation, so it looks a bit scary, but yeah, it's just a dot at the moment, right? So that is simple enough. So we have the Hamiltonian, the current objective, plus the co-state variable lambda, call it a multiplier, and the change in the stock variable. Now, with Lagrange, you write down the Lagrangian, and then you write down the first order condition that optimizes Lagrangian, right? And there's two first order conditions typically. You take the first partial derivative of the Lagrangian to the thing that you decide on, and then you take the first partial derivative of the Lagrangian to your shadow price, to your Lagrange multiplier. Not quite like that, but very similar. The first order condition is actually very similar. You take the first partial derivative of your Hamiltonian, dH, to the thing that you decide on, that is how much to consume this year. So we have dH dC, and that must equal 0. This is Lagrange, but with an H instead of an L, right? So dH dC is marginal utility of consumption, and because K depends on C, right, or K dot depends on C, as you can see here, we have a minus lambda here as well, and this must equal 0, so marginal consumption equals the shadow price of capital, right? This is bog standard. The thing that is not standard is the dynamic first order condition, and that is a very weird thing. That is the rate of change in the multiplier, in the not Lagrange but Hamilton multiplier, minus the discount rate times that thing is equal to the first partial derivative of the Hamiltonian to the stock variable. And this doesn't resemble anything you know from Lagrange. This is just a thing that, well, I can prove it to you that this is the case, but it would suffice just to recall or confine this to memory. So it's lambda dot minus rho lambda, always there, and then is equal to dH dk. Now this is a differential equation. Differential equations are absolutely horrendous to solve. Differential equations are a bit like integrals. There is actually no generic solution to them. But fortunately, we don't have to solve it. We just have to, well, we actually gotta completely ignore it in this particular application. If you would do resource economics next, which we don't offer, you would actually have to interpret and work with this differential equation, but that's not what we're going to do. So, we have the Hamiltonian is utility plus the shadow price times the change in the capital stock. But we know that the shadow price, U C lambda, is equal to U sub C, first partial derivative of utility to consumption. So we can substitute this lambda by marginal utility, right? So we have this expression here, and then we can linearize the thing. Utility is always equal to consumption times marginal utility, approximately. And this thing just remains as it was. And then what we can do is divide both sides of the equation by marginal utility. And then we have consumption plus the change in the capital stock. This is net domestic product, right? It's consumption plus investment minus depreciation, the change in the capital stock. Now, the reason that we need to divide the Hamiltonian by marginal utility is because the Hamiltonian, as you can see here, this is measured in utils. It's not measured in pounds. It's measured in utils. Now, your change in the capital stock is measured in pounds. So your co-state variable, your Lagrange or your Hamiltonian Hamilton multiplier, must be measured in utils per pound, right? Otherwise, you can't add the two. right? So now we also have the unit of this thing. But your Hamiltonian is measured in utility, not in money, which is awkward because we don't know what to do with utility in terms of measurement. But of course, if we divide it by the marginal utility of consumption, the unit of which is utils per pound, we go back to monetary terms, and what we have is that the linearized, monetized Hamiltonian is net domestic product. And this happens along the optimal path, right? So, Marty Weitzman was the first to notice this in, I think it was 1972. So now we have a welfare justification for the net domestic product. Can we do the same for the environmental product? The answer is obviously yes, otherwise I would not have asked the question. And this is due to a much older Weitzman. Still cocky, but a lot less hair and a lot more gray hair than he had when he was young. I shouldn't make fun of him, he's a great guy, was a great guy. So, we're gonna change our utility function. It now depends both on consumption and the state of nature, and let's call that N. I'm also going to introduce environmental protection, P, and that costs money. So the change in the capital stock is depreciation. This is total production still, and we take away some of total production for consumption, and we also take away some of that for environmental protection, investments in nature, right? So we have less money to invest, less money to consume. We have a second equation of motion, and that is that our environmental capital stock N changes, that's the N dot, and it depreciates or restores itself, that's theta, and then we can also invest in it, and this is our environmental protection effort, right? So those are the additions to the model. Now the Hamiltonian looks as follows. Our current objective has changed. We now have an n in, but we still throw away the integral sign and the discount factor, and of course then also the dt, right? That goes with the integral sign. But it's still just instantaneous utility that now depends on two things. We still have the Hamilton multiplier times the change in the capital stock, as we had before. Now we actually have two equations of motions. We have two stocks that we care about. So we should also add the change in the environmental stock times its Hamilton multiplier or co-state variable, its shadow price. And we call that mu, because that is the letter that comes after lambda in the Greek alphabet, right? Two things that we care about, two stocks, so we have four first order conditions. The first order conditions that have to do with consumption and capital are as they were. Marginal utility equals the shadow price of capital, and we still have how this thing changes over time. Lambda dot minus rho lambda is equal to the first partial derivative of the Hamiltonian to the capital stock. The first partial derivative, the second set of first order conditions, is that the first partial derivative of the Hamiltonian to the other thing that we decide on, we now make two decisions, how much to consume and how much to protect, how much to invest in environmental protection, P, that is actually shows up in cap k dot. We have minus p, so we have minus lambda. And it shows up in n dot as well. So we have a minus lambda and a plus mu. That is actually very convenient, right? We just find that the two shadow prices are always equal. And then we have this awkward differential equations that mu dot minus rho mu is equal to the first partial derivative of the Hamiltonian to the environment stock. But again, we're gonna ignore that, right? So yeah, that first order condition is there, but we're not gonna use it. We're just gonna use the static first order conditions. So previously what we did was we just took the Hamiltonian, linearized it and monetized it, and then we found the net domestic product. So let's do that again, right? And see what we find this time. So the Hamiltonian is equal to utility, right? Plus lambda k dot, or lambda k dot. We know that lambda is equal to marginal utility, so we can substitute that in here. And mu n dot, right? We know that mu is equal to lambda is equal to marginal utility. So we have this expression here. Then the second now I'm a little bit confused what I'm doing here. So this thing just, but where does this term come from? Oh wait, this is where that term comes from. Sorry. So this thing ends up here, this thing ends up here, right? We said we would linearize utility. So utility is the first partial derivative of utility to consumption times consumption, right? Plus the first partial derivative of utility to the natural stock times the natural stock. So that is n times u sub n, right? These are the two linearized components of the utility function. And then, just to confuse myself, I multiply that thing by marginal utility over marginal utility. So I multiplied it by 1, and that is what I did not immediately see. So this is just the first order Taylor approximation of this thing here, right? Now the final step that we took last time was divide both sides of the equation by marginal utility. So let's do that again. This thing, expression here, we divide by u sub c. So this becomes c, this becomes k dot. So this is net domestic product. This thing here becomes just n dot. This is the change in the environment, and this is the stock of the environment. And look at its correction factor that we see here. So un, u sub n, is the marginal contribution of nature to utility. We divide that by u sub c, the marginal value of consumption. So this is a price ratio. This is the price of nature in utils divided by the price of consumption in utils. So this is actually the monetary value of the environment, right? It's the relative price of nature in utils to the relative price of consumption. It's the price of nature relative to the price of consumption. One is divided, has as its unit utils per nature, the other has utils per pound, and then the result of that is nature, pounds per nature, right? And this is the environmental domestic product along the optimal path, the monetized linearized Hamiltonian equals the net domestic product plus the monetized value of nature, this expression here, and its increase. And that is exactly what I did intuitively before, that we should just add all those things that nature gives us, all the things, nice things that the environment gives us, and we should subtract how much the stock of good things out there has changed. Now, this is a fairly stylized way of doing things. Obviously, there's many more things that enter into our utility function that matters to us. The inside doesn't change, right? I can do this derivation with 15 inputs into the consumption, into the utility function, and then with 15 stock variables, and that means 30 first order conditions. The result of that would just be an equation that is very, 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 very long, but doesn't give you any additional insight, right? Similarly, with the growth accounting that I did before, I did it with 2 inputs. I could also have done it with 15 inputs. The insight would have been exactly the same, right? So, the environmental domestic product that I put up a while ago actually has a proper welfare justification thanks to Professor Weitzman, right? So, that's it for the moment. After the break, I'm going to abandon theory and I'm going to talk about how is this done in practice. And I'm going to show, I think, 4 examples of actual environmental accounts. So, before the break, I talked about the theory of defining economic welfare in an expensive sort of way. Expensive with an A. That is theory. Nobody has really succeeded in putting this into practice yet, although people are attempting to do this. And that is what I'm going to talk about for the next 50 minutes or so. The first sort of measure that was actually proposed at the same time as the Weitzman paper came out in 1972 by Bill Nordhaus and Jim Tobin, who you see here. Nordhaus on the left, much younger than Tobin was already advanced in age. Both Nobel laureates for very different things. And essentially they proposed a measure of economic welfare, which is a measure of consumption, not production, and it's essentially net domestic product. And then they subtracted all the things that are bad, but economic activities nonetheless, such as repairs, pollution control, medicine that you buy, and that sort of stuff, all the stuff that you actually would rather do without. They also subtracted what they considered regrettable necessities. So that is the police force, the military, do not really contribute to welfare. These are defensive expenditures. They added household production. They added illegal production, and they added leisure to it. That was the theory. They themselves consider this to be primitive and experimental, but it actually has quite a history of people essentially redoing this, but calling it differently. So this comes under the name of sustainable economic welfare, genuine progress, sustainable net benefit, domestic progress, and so on and so forth. That has been, they tried to measure this for the United States in, I believe, 2007. Yeah, that's what it says. So this is gross domestic product, but then if you start correcting for all the bad things as well as adding some of the good things, you actually see that the US economic performance isn't nearly as impressive as it seems to be. that is over this period, per capita income rose from 12 to 36,000. That is a threefold increase, 1950 to 2005. Whereas if you include for environmental stuff and so on and so forth, it rose from, let's make it 7.5 to 15. So that is a doubling, right? So much less progress. And perhaps more importantly, since the first oil crisis, 1973, essentially there's been no progress in the US economy. If this is the right way of measuring things, of course. But you see the stark difference, just as we saw with the Repetto figures, a stark difference with the economy, with and without correcting for the environment, and so on and so forth. There's all sorts of issues here. How do you put values on things? How do you value the depletion of non-renewables? How do you value the cumulative costs of environmental damage, sort of the environmental stuff that accumulates in the atmosphere, like what is now called forever chemicals, what we used to call persistent organic pollutants, sort of the stuff that lingers, or how do you account for nuclear waste that just stays with us forever and ever, and well, not forever, 10,000 years or so. Of course, there's arbitrary choices. To what extent is the police something that is a regrettable necessity, and to what extent do they actually bring proper public goods and services, right? Of course, the main role of the police is to prevent crime, but you also have sort of the social function that at least a good police force brings, right? And because of that, these arbitrary choices, actually, it's not something that is hard in the sense that everybody would come up with the same result. Important thing to realize here is that this is a measure of weak sustainability, right? Again, we're looking at the sum total of economic welfare, and we don't really care where it comes from. And if we can substitute environmental consumption by material consumption, then that is perfectly fine, right? So we assume substitutability here. That measure that I just showed, or that family of measures that I just showed, that go back to Nordhaus and Tobin, is not at all how the national offices of statistics do things. They do things in quite a different way. The United Nations is trying to standardize this, but it's not really succeeding. So instead of looking at the UN system, I'm going to look at the UK system. The UK has, that is the Office for National Statistics, has two environmental accounts. One is called the environmental accounts, the other is called the natural capital accounts. And I'm going to show you examples of both, or just I'm going to sample through it because there's so much there that it just would get very, very boring. There's a couple of things to note about this, that at the moment the environmental accounts in the UK are limited to emissions to air. That is stuff that we dump in the water, sewage, or stuff that we dump in the soil, dioxins and so on and so forth, are not accounted for. This is of course a serious omission. It also reflects we are obsessed with climate change and air pollution, right? And to the neglect of other environmental problems. Same for the second point, right? There are enormous detail in the energy and greenhouse gas accounts, much less in other environmental problems. And that is the political priority, even though ONS is not supposed to follow politics. There is information on particulates and on heavy metals, right? And I'm going to show you an example of one of the metals in a second. The environmental accounts also include, and all this is done basically in the physical units. So tons of CO2 emitted and grams of lead emitted, right? Fortunately, not tons of lead. All of that is in the physical measures, but there's also expenditure on environmental protection. Basically, how much companies spend or say they spend on cleaning up the environment. There is information on environmental tax revenue, which includes a lot of taxes on consumption. And it also has the material flow accounts. And the ones in boldface I'm actually going to show examples of. And as I said, there is a lot of information. This are the vanadium accounts. Now, you don't know what is vanadium. It's bad for you. So these mushrooms are poisonous. Don't eat them. Some mushrooms give you pleasure. Some are tasty. These will kill you. And the reason for that is because they have lots of vanadium in, which is a heavy metal that you should not eat or otherwise ingest. And what these environmental accounts show you is, and you can't read this, from 1990 to a few years ago, for all economic sectors, both the gross aggregation, which goes from A to Z, but skips a few letters, so that's fewer than 20, but also for the detailed environmental economic sector, so that goes to up to 100 alternative economic activities. It tells you per year how much vanadium these sectors, these economic activities emit, right? And what you see, if you're interested, is that most of that stuff comes out of transport and storage economic activities. So it's essentially road traffic is where it comes from. So if you're interested, you can trace vanadium. You can do the same thing for zinc and for copper and for lead and for cadmium and what have you. So this tells you where exactly does the environmental pollution come from, how that changes over time. It also tells you that if you want to regulate this substance, these are the sectors you should target, right? Because this is the main source of the material. It tells you tax revenue and who pays those taxes. Here we compare 1997 and 2016. It is given in, I assume, constant pound sterling. It doesn't say so. What you see is that in 1997 the bulk of environmental taxes was paid by green, that is by the households, that's you and me. But by 2016 even, the tax burden has actually shifted substantially towards different parts of the production economy. So services, manufacturing, and so on and so forth. So you see a shift in the tax burden away from households toward companies, at least between in this particular decade. And you can trace this over the years, right? So that is hopefully useful information. And of course you can also compare this roughly 50 billion to the total tax take and say, well, this is the total extent of environmental taxation in the UK. I also have material flow accounts, which again in physical terms, tons, tell you what stuff comes from where, right? So what this particular table tells you, and I downloaded it a couple of years ago, but now it goes to 2021, I believe, that in 1992, 91 unit isn't there, it's somewhere, it's probably 91,000, but maybe 91, it's probably 91 million, but it may be 91 billion tons of limestone and gypsum were extracted from places like the South Downs, right? And there's a little bit of this activity still going on. And you see how that changes over time. You see sand and gravel You see iron, iron that is being mined in the UK. There's iron mined in the UK. You see crops, you see fish caught, not in the territorial waters, right? So this is domestic extraction, and then they have similar accounts for materials imported and materials exported, right? So you can do a lot of that stuff, and I'm just showing you snapshots, right? They have tons and tons and tons of material where you can really trace what is what, right? Then they have the natural capital accounts as well, and the reason that there's two is because there's two groups in the ONS and they can't agree with each other what to do. So there is a little bit of overlap between them. They have different advisory boards and so on and so forth, and they tend to disagree with each other on what to do. The natural capital accounts essentially follows the ecosystem services that I talked about, I think in week must have been week 4, right? So they look at the provisioning services that are provided by nature, they look at the regulation services provided by nature, and they look at culture. And part of this stuff is actually properly monetized, but that comes a little bit later. So these are the provisioning services. It actually gets sort of on the same terrain as the material flow accounts, but here we see them over time. This is all monetized. In red, you're looking at fossil fuels. And what you see is that red actually used to dominate natural provisioning. This was the most valuable stuff that we got out of nature. But then, of course, production in the North Sea was wound down, and the oil price came down as well. So that wasn't worth that much anymore. In blue, you're looking at the total value of agriculture. In orange, do we see orange? Do we see orange? Orange is what got us Brexit, right? We're going to save the fisheries industry from the clutches of Brussels. But what you see is that, oh, it's actually here. If you look very closely here, you have good eyes, you can see a little bit of fisheries there. So that is the sort of information that you can glean from this. This is important. This is where do our pollutants go? Particularly where do the particulates go? Because they are emitted, and some of them end up in your lungs and make you ill, but most of them, a lot of them, actually are absorbed by trees. Thank you, forest, for doing this for us. If you look at NH3 ammonia, if I'm not mistaken, actually it is pasture lands that absorb this particular substance that is mildly harmful to humans, more harmful to other mechanisms. So this tells you a little bit what does nature do for us in terms of cleaning up our mess, right? It also has time use. This is million of hours spent outdoors. And where do you spend your time outdoors? And no surprise at all, because most people live in cities. Most time outdoors is actually spent in cities. Most people prefer to be in other places, on the coast or in the forest or on farms, but that is a bit further away to most people. And as I said, they also monetize the whole thing. So if you then put a dollar value on this using travel cost methods, particularly, and the picture actually changes. Cities become less important. They're still important because people spend so much time there, but because less important because people spend so much time there, so it's less scarce, and therefore the price and the value of it is lower. and people actually prefer the coast much more than that. Also, people in the UK prefer farmland over closed forest, because in a forest you cannot see very far, but on a farm you can. So all that information is there. Here I stopped in 2017, but of course they continually update this. So this is what the UK is doing, and it is one of the most extensive environmental accounts in the world. It's probably the most extensive in the world. The World Bank is doing something different. The World Bank is using what they call, used to call genuine savings, but nowadays call adjusted net savings, which is really, really ugly term, right? So the guy behind this is my old friend Kirk Hamilton, who you see here, and he drives this project at the World Bank. So as I said, the United Nations is trying to do this, but being the United Nations, it is not really getting things off the ground as quickly as perhaps they should, because the United Nations, essentially every decision has to be made by consensus, and that just doesn't really work. The World Bank can act more independently, and a single person at the World Bank can actually occasionally achieve things. So that is why the World Bank is faster than the United Nations, even though it is the job of the United Nations to do this. So they introduced this thing called genuine savings, and then people started screaming at them, and then they renamed it into adjusted net savings. The reason that they started screaming is because it is incomplete and therefore not truly genuine, right? So essentially, adjusted net savings is the depreciation or investment minus depreciation part of the net domestic product, and then corrected for the environmental stuff as well as some other things. So it's essentially how the total stock of natural capital and manufactured capital changes. And so they have net investment, that is investment minus depreciation. In physical capital, they have net investment minus the depreciation, the degradation of the natural environment. And then they also have the same for human capital included. So essentially genuine savings or adjusted net savings is the environmental domestic product plus human capital, but then without the consumption part, right? That is essentially what they have. And this is an immediate indicator whether or not an economy is sustainable, right? Because if your genuine savings is lower than zero, you're essentially eating up your capital. You're not investing in the future, you're disinvesting. You're sweating your assets. Whereas if your genuine savings is greater than zero, then you're adding to the total capital stock. Again, because they just add up things, they assume that human capital is a substitute for natural capital, and human capital is a substitute for physical capital, manufactured capital, right? So this is a measure of weak sustainability. There's no strong sustainability here at all. I'll come back to that in a short while. So that is the theory. Net investment in manufactured capital minus net depreciation of natural capital plus net investment in human capital. Note that they assume that human capital necessarily grows, right? That's necessarily positive. Same for physical capital. But the environment is always deteriorating according to this. But that is the theory. In practice, this is what they do. So they look at the extraction of fossil fuels and minerals and forest because they have data on that, but not on all the other things, right? That is excluded. For the UK account, we had gypsum and we had sand and we had water and we had this and we had that and we had fish, not in the World Bank data, because that data does not exist for most countries in the world. But we do know we have good accounting for energy and therefore for fossil fuels. We have good accounting for minerals because they're so important for industry. And we can see forests from satellites, so we have a good idea of what's going on there. But for a lot of other stuff, we simply have no clue. They count CO2 emissions. And then they had to put a value on that, and the value that they put on was $20 per ton. I may be responsible for that number. It's a number that most people would now strongly disagree with. And then they also included the damage to health done by PM10, not PM2.5, not other air pollutants, only this particular form of pollution. So it is very, very incomplete. I mean, the idea is fine to do all these things, but then to do this for every country in the world, and that is of course what the World Bank needs to do, you simply run out of data very, very quickly, and you would essentially have to replace things that are properly measured with guesses about what the number might be. And then for human capital, they don't know. So they looked at the amount of money that is spent on education, both capital expenditure and operational expenditure, and they assume that all those money spent actually go towards learning. It is, you may have guessed, not an entirely correct assumption. And they also completely disregard any depreciation of knowledge. That there are certain things that used to be valuable knowledge, but because of changes in technology are no longer. I gave you probably the example that when I was young, we spent a lot of time doing fairly complex computations in our heads, right? And I'm still very good at it, and it's a completely useless skill because I walk around with a smartphone with a very good calculator, so I don't need to do this anymore, but I still can do it, right? And it's just useless knowledge that I carry around. But that is how they measure these things. So what do the numbers look like? This is for Bolivia. There's no Bolivians in the class, right? So gross savings, so this is investment minus depreciation, is around 12% of gross national income. Then, oh wait, that is gross savings, so that is just investment, right? If you then subtract depreciation, it comes down quite considerably. You add investments in education, it goes up again. You subtract PM10, now it becomes negative, and Bolivia all of a sudden doesn't look so sustainable anymore. Oh wait, I skipped a step. This was the pollution damage. What they did here was, this is Bolivia, they included deforestation in the Bolivian part of the Amazon, is what they did here, as well as some of the mining activity that is going on. Then it doesn't look so sustainable anymore. And then if you then also subtract CO2 and PM10, then Bolivia looks pretty unsustainable, right? So if you just focus on the economic part, then the capital stock of Bolivia is growing. If you then add, it's also investing in its young people, so it seems to be doing fine, but all of that comes at the expense of the environment, and actually if you correct for that, then the Bolivian capital stock is shrinking. of course, if you believe the numbers that Kirk and colleagues put in, right? You can do it for Bolivia. You can also do it, of course, across the world. Some countries are doing fine. Where are we? We're part of the OECD. So that is here, hiding behind the world. So genuine savings are actually positive throughout the period. Other parts of the world, this is North Africa and Middle East, are actually doing pretty badly, and that is because most of the growth there comes from oil extraction, right? And it is they're running down their capital stock. So hopefully this is useful. You can also compare it across countries. Some countries are doing very well. Sri Lanka, Panama, Morocco are at the top. Sweden and Denmark, of course. Other countries are doing very, very badly. The one at the very, very bottom is Liberia, where actually there almost 90% of their income comes from running down their capital stock. You can't keep that up for very, very long, right? You can keep that up for a very short period only. So Liberia is in a very bad place, if these numbers are to be believed. Of course, there's all sorts of stuff missing from these genuine savings. Fisheries isn't there, soil erosion isn't there, water pollution isn't there. Diamonds are even missing, even though we have, well, do we have good data on diamonds? There's a lot of illegal trade, right? And they're working on this, but not quite there yet. As I said, human capital, they don't account for knowledge becoming obsolete, but they also don't account for people dying and taking whatever they knew with them. So, imperfect, but better than nothing. Now, all of these measures are weakly sustainable, right? That is, capital stocks can be substituted for other capital stocks. And you should not be surprised that there's also attempts at measuring strong sustainability. And I'm going to talk a little bit about this. I'm going to show you 3 examples. The first one is actually very popular for reasons that are completely and utterly beyond me. And a lot of people talk about the so-called Human Development Index. And that is sort of, in some circles, replacing GDP as the thing that we should really, really care about. So what is the Human Development Index? It comes out of the United Nations. It takes 3 things. One is it takes GDP per capita. So even though it's supposed to replace GDP per capita, it actually takes GDP per capita. Then the second index that it takes is life expectancy at birth, without adjusting for quality of life or anything, just like living longer is better. And then it takes a human capital as a mix between the fraction of adults that can read and write and the fraction of kids that are in school, supposedly learning how to read and write, which is not true in every school. Then what it does is it takes these measures for all the countries in the world for which there are data, rescales them from 0 to 1 for each year, and then takes the average of those normalized scores. That is the Human Development Index. It sounds simple, it is simple, it is actually a very strange thing to do. Because if you scale things from 0 to 1, actually what matters for your relative position is how far away are you from the maximum, not how well are you doing, but how far away are you from the maximum. So if some of these countries have sort of like strange hiccups in their data, So one of the richest countries in the world are the Bahamas, right? Which is a very tiny country, and some of the things that are going on in the Bahamas are a bit dodgy in the banking system, the financial system more generally, and they also have a very big reinsurance part of their economy. So if you have a couple of big earthquakes and a couple of big storms, then GDP per capita in the Bahamas dives, not necessarily how wealthy the people are in the Bahamas, but because a lot of financial accounting goes through the Bahamas. So if you have such a shock, then GDP per capita in the Bahamas dives, and that means that all of a sudden we get closer to the maximum. So we just jump up in these rankings, right? So it makes very little sense to do this normalization at every period in time and to normalize on the maximum. And the maximum typically is a small country that is an outlier for reasons of being a small country. So it is a most peculiar measure, but it is used quite a lot. Another one that I came across is the Happy Planet Index, which sounds wonderful. The Happy Planet Index is very strange. So it is defined as life satisfaction. So there are now these routine services that ask you how happy are you in general with your life. And that question is asked all over the world and routinely. So we have decent data on that. And it's very unclear whether this really measures things like life satisfaction or whether it measures something like culture. Because of course in this country you are not supposed to say these things. If you are in the United States, you are supposed to say, somebody asks you, how are you? You are supposed to say, I'm well, right? You're not supposed to give a truthful answer to that question. If you go to Eastern Europe, then it is part of the culture to be miserable, right? That is part of national identity. So you sort of like see these systematic differences in the way different cultures respond to a question like how happy are you, how satisfied are you with your life on a scale of 1 to 10? That question means very different things to people in different countries. But the assumption here is that all people are the same and give the same answer to this question. So they take life satisfaction, then they multiply that with life expectancy. So unlike the Human Development Index, it's not how long do you live, but also corrected for how satisfied are you with your long life. So that seems fine, although multiplying the two is a bit peculiar perhaps. And then they divide it by the ecological footprint. And division is always a very dangerous thing. So life satisfaction, the most miserable country says it's 2.7. The most happy country, which I believe is Denmark, but it may be Finland, says it's 8. So that is the numerical limit that you see. Life expectancy ranges from 44 to 75. And then the ecological footprint ranges from 0.02 to 100. And of course, if you divide by a very small number, then you get a very big number, right? So this measure is actually completely determined by the ecological footprint at the bottom end, right? Because there you divide by small numbers, so you see very large jumps in numbers. So this is what the Happy Planet Index looks like. The most happiest country in the world is Vanuatu. Second one is Colombia, then comes Costa Rica. Cuba is number 6. Who would like to move to Cuba? Right? Weather is wonderful, the people are very nice, but other than that, it is a bit of a mess out there. Let's zoom in where we are. The United Kingdom is ranked 108 in the world, just below Libya, right? There's a civil war raging in Libya, right? It is that poor, it is very, very dangerous. Don't take this as an advice on where to spend your holidays or where to migrate, right? It just doesn't make any sense. The United Kingdom is very close to Laos, which is very poor, still very communist. No, this does not make sense. So, I skipped the ecological footprint. The Happy Planet Index uses the ecological footprint. The ecological footprint is a measure of strong sustainability. It was introduced by these two guys, Ries and Wackernagel. And it's Wackernagel who is actually the main champion of this. William Ries is a sort of a very considerate academic, right? Thinks deep and long about things. Wackernagel Matthias is more of a showman and goes around selling this particular product and is doing so very, very successfully. And for those of you who read, say, The Guardian, would have come across the ecological footprint because it's always in there. So essentially what they try and do is measure things in land equivalents. So the idea is that we have a finite amount of land on the planet, and the question is, do we implicitly use more resources than we have, right? So you could see this as a measure of strong sustainability. And essentially the measure translates everything, or everything they could get their hands on, into their land equivalent. And sorry, by doing so, they essentially, we go back to the physiocrats, right? You may recall from the introductory lecture on valuation that the physiocrats thought that because God touches nature and we touch nature, this is sort of where we touch God, and therefore land is the true yardstick of value, right? The physiocrats had this absolute notion of value, and they tied it all to land. And essentially, the footprint guys do the same thing. So this is how it works, right? So we have CO2 that goes out into the atmosphere. We don't like that. So how do we value the CO2 that we emit? We compute how much forests, how much trees should we plant to suck that CO2 out of the atmosphere again. And you need so and so much land for that, right? And that is the ecological footprint of our CO2 emissions. Grazing land, that is simple, right? That is the amount of land where our cattle live. Forests, that is simple as well. And so on and so forth, right? These are actually fairly natural ways of converting things to land, but if it comes to emissions and waste, it is actually a different story. So that is what they do, and this is literally all they do, right? So the CO2 goes into the atmosphere, how much trees should we plant to suck it all out again, and then the other is just like, what space do our crops take, what space do our cattle take, what space do we take, right, in cities. The fisheries are a bit weird. Essentially the question is there, what if we stopped fishing and started growing the necessary proteins on land? How much land do we need to substitute fully for the fish take? That is a bit bizarre, truly. Now, if you add up all these numbers, you get to something like this, right? So this is the urban area. This is croplands, fishing, if we would do fishing on land. This is the forest that we use. This is the grazing that we use. And this is the CO2 emissions if we would suck it all up by planting trees. And then over time, since 1961, don't do this, this is what happens. And then the one that you see here is how much land is there on the planet. And what you see is that since 1974, or maybe 5, we have been using more land than we have. And that then, of course, immediately implies that we're running down our resources, right? We're running down our capital stock. And that is a bad thing. And now these numbers are for the world as a whole. You can do this for every single country. And then in a popular way of doing, of showing this is to look at the overshoot date. So what you see for the world as a whole is that in 1974 or 1975 we started exceeding this. By 2007 we exceeded it by around a quarter, right? We used 1.25 roughly of what we had. No, it's more like 1.4. So that means that essentially we started running out of stuff in late August, early September, right? So for the world as a whole in 2007, the overshoot date was that, say, from the 1st of September onwards, we were using resources that we did not have, right? We were running down our capital stock. And you can calculate this particular date for every country in the world. Here you see for the year 2020, Qatar is the worst in the world, right? It did not even make it to mid-February. That's because of all the oil that they get out, right? Luxembourg is the second worst. Where is the UK? The UK is May 16, right? So for sort of 4.5 months in the year, we were sustainable, but from mid-May onwards, all the stuff that we consumed was more than we had, right? So we were running down our physical capital stock. Now, what is wrong with all this? Well, as you saw, that actually most of the ecological footprint comes out of CO2 emissions. And that is very awkward because emissions are not about land, right? And the way they did it was we're gonna plant trees to sequester this CO2. And that was the only option available, not substitute fossil fuels by biofuels. It also takes up land, but actually is much more land efficient. Similarly, wind turbines would be, in terms of the amount of land used, would be much more efficient in avoiding that CO2. And of course, the only way to get CO2 out of the atmosphere is by sequestering it in trees rather than by improving energy efficiency, like home insulation, right? All these things are sort of like excluded from this measure. So it is very peculiar. They focus on CO2 as if climate change is the only environmental problem in the world. Plastics aren't there, sewage isn't there, pesticides aren't there, nuclear waste isn't there, right? So it is a very limited measure. Those things are even more difficult to translate into land equivalent. That was a good thing in the first place. They ignore water use. Again, how would you substitute land for water, right? They're complements, right? Water on its own is not much good for us humans because we're not fish, right? So we need land to stand on and put our crops in, but then those crops won't grow without water. So land and water are complements for humans. And therefore it's very hard to sort of say, well, I have less water and therefore I'm going to use more land. No, that doesn't work, right? That does not make crops grow. The world overshoot dates that I showed here take a very particular position on international trade, and it sort of perhaps makes sense to do this for the world as a whole, because these are the resources we have for the world as a whole, and we should not use more of that. But as soon as you do that for a particular country, you're essentially saying, well, international trade is not allowed. And the reason that Luxembourg scores so very poorly here is it's because it's a very small country, very densely populated, very rich, so most of the stuff in Luxembourg comes from other countries. There's actually very little, there's a little bit of agricultural production in Luxembourg, but most of it is banking and finance, what they do there, and all other stuff is imported, right? Because it is such a tiny country. Similarly for Singapore, which I can't see, Singapore is here. Singapore is essentially a city-state, and essentially they're saying, well, city-states are not allowed. By definition, city-states are very open economies where most of the stuff is imported and most of the stuff that they make there is exported, right? And essentially what they're saying is, no, you can't do that, right? So it takes a very strong position against international trade. It is in a way a measure of strong sustainability in the sense that we focus on natural capital, and in the sense that you can't substitute physical capital, manufactured capital, human-made capital for natural capital. That is not possible within the ecological footprint. But of course it does assume substitutability between different kinds of natural capital by aggregating everything up to its land equivalent, right? So it's not the strongest form of sustainability, but it's definitely stronger than genuine savings, environmental domestic product, and so on and so forth. So that's it. There is more corporate accounting, but we're going to do that in the seminar on Monday. Okay, I hope to see you guys then.